start recording. Okay, so let's just give 30 more seconds for people to join. All right. So in a CSTR, I warned you about that conversion thing. But so in a CSTR, two things can be unknown. You can have to solve for the volume, or you have to solve for conversion, which is the molar flow rates that will then be unknown. This is an easy one. You don't need an fsolve function to solve for volume, because in your mole balance, you can just, if you know X, you can just solve that directly, because everything will be known except the volume, which is an unknown in that equation, right? So, but if X is an unknown, it becomes a bit more complicated. You can still get an analytical equation. And then I see some people write both mole balances, because you actually do have the lots more unknowns, plus pressure is equal to 0, and then try to solve for FP and FA, as you know, trying to stay away for conversion. However, for single reactions in a CSTR, it is really good, because you know conversion must be in a range of values between 0 and 1. I would suggest for single reactions, still solve in fsolve for X. So your function will look like this. You will define your CSTR function, and you will solve for X, right? So you're going to put in a first guess value for X in that CSTR function, and then you can calculate your FA is equal to FA naught, 1 minus X. You can calculate your FP. Remember, there was an FP initially present times X. You can calculate your concentrations. Right, in my function, I like doing everything in my function. It's easy for me to find the error. So then let me just make more space. And then I can calculate my rate of A. And it's CA times CP. I think that was that rate. And now the function I want to return, my residual value, the thing that I want to be equal to 0 is, of course, going to be equal to my mole balance. Right, so the mole balance must be equal to 0, and I'm going to have FA naught, which was hopefully now defined in my parameter value. So that's one of the constants, it's not one of my local variables, minus FA, which I calculate for each guess value of X, plus RA times the volume. And in this case, the volume was a known parameter, so it's a constant, so it's also outside my loop. That's a global variable, right? So this is what I am going to return. So I return this resultant, the res value, and if I now have to solve, I can get my conversion in the CSTR on the next line will be equal to fsolve, and then my CSTR, and I have to guess an X value. And for single reactions with a single variable, so what I can do with single reactions, I can still write all my unknowns as a function of a single variable. You will see when we start writing our energy balances or go for multiple reactions in a CSTR, remember that reaction coordinate epsilon that we treated in CTD. So we are going to use that. We can use that again to solve that. So if you an alternative approach that I saw some of you are using is that you are using the CSTR and you have your variables that you want to solve is then FA and FP is equal to your variables. And of course that will work as well. Then you need two equations that must be returned. So you will have residual 1 and you will have residual 2, and this will be the mole balance for A and the mole balance for B. Okay. The problem with this approach, or the sneaky part, that for me, you may not find it problematic, is that then you have to guess values for each of these, right? Instead of a single x value, and at least you know x will be inside a defined range. And F-solve can be very finicky if you, for some of the very non-linear equations in order to try to solve that. So I am going to ask for questions. Any questions from anybody regarding this? You can put up a hand if you've got a question or type something. So that's just my advice for solving the CSTR. So if you've got the answers, ask in your groups if you've got answers, and some of the TAs may come and confirm whether you've got the answers correct for the CSTR. And of course, that's why the plug flow reactor, the PFR, okay, let me just clean the screen. In the PFR, in those first problems, the PFR is much more difficult in part B, because that's where I want you to use solve IVP with an event where your conversion is 85% to find that volume. So for the CSTR, A is like that's giveaway marks. That is like in minimum requirements, you must get that correct. But in solve IVP, there's some skill required. So if you struggle with solve IVP with the syntax, please shout, ask in your group, share your code so that we can help you out, so that you understand what that very useful function can help you with. Right, questions from the floor or from the online floor? Crick, crick, crick. Online people, are you there? Crick, crick. I think they abandoned us. No questions. Yes, there we go. But Camille, aren't you here? Okay, all right. Okay, all good. I'm going to stop the recording.